Today we're going to be solving trigonometric equations. As you can guess, it's an equation, so it's going to have an equal sign and it's going to contain trigonometric functions. If you have these two ingredients, then you have a trigonometric equation. I'm going to teach you the simple steps for solving these equations, starting with the first example. First example 1 says cosine of 2 theta is equal to sine of theta. We want to solve for theta, so the question is, what is theta? So a couple things to note here. First of all, you can't use normal algebra to solve this off the bat. In other words, you can't square it. You can't divide by 2 theta. That's restricted within the parentheses. And furthermore, we have two different trig functions. We have a cosine on the left and the sine on the right. So it can't be solved with simple algebraic means, at least for now. Another thing to note is we do have a domain listed. This is only for any angle theta between 0 and 2 pi, including the endpoints. So that's important because if we didn't include a domain, there could be infinitely many solutions for theta, and we're just going to stick to a restricted domain. So with that being said, let's go ahead and learn the simple steps to solving trig equations, starting with step 1, and these are going to be the same steps for every example. Step 1 is to move all of the trig functions to the same side. Now notice it says move just the trig functions. If you have any constants in the equation, you do not need to move those to the same side. Now typically by same side, I usually mean the left side. So first step is we're going to subtract sine of theta from both sides. In other words, if I wanted to show it this way, I'm moving sine of theta to the left-hand side by subtracting it. After we do that, we get cosine of 2 theta minus sine of theta is equal to 0. So that completes step 1 of moving all of the trig functions to the same side. Like I said, by convention, I usually move them to the left. Step 2, write all of the trig functions in terms of the same angle. It's really hard to solve a trig equation if you have a 2 theta and a theta. So you want to get everything in terms of usually a single angle theta. Okay, so that's why it says preferably a single angle. So I know that this is a double angle, and if you look back at the double angle lessons, which I recommend you do if you haven't already, you will see that cosine of 2 theta has its two separate formulas, one in terms of cosine and one in terms of sine. Now, because we want the entire equation to be in terms of the same trig function, we're going to use the double angle formula pertaining to sine. That is that cosine of 2 theta is equal to 1 minus 2 sine squared theta. And of course, over here on the right, it stays the same. So now we have 1 minus 2 sine squared theta minus sine of theta, and we've completed step 2 because we've written everything in terms of one trig function, namely sine of theta. And we also want it to be in terms of the same angle. So sine squared of theta is actually just of a single angle. So if I just do this in blue, for example, okay, it is being squared, but it's still only of a single angle. So that completes step 2 of writing in terms of the same angle. And again, I did that because I knew cosine of 2 theta is a double angle. And I can write in terms of a single angle using 1 minus 2 sine squared. I've already alluded to the next step. A lot of times when you do step 2, it gets combined with step 3. If possible, convert all the trig functions into the same trig function using formulas. So in other words, I want everything in terms of either sine or cosine or tangent or whatever. I just want the same trig function across the board if I can. Now you can't always do it, but I do recommend for step 3 doing it if possible. In this case, it's already taken care of. Step 4, you want to replace the trig function with a variable. Now this is kind of optional, but it makes this formula simpler. Whoops, didn't mean to do that. So in other words, instead of writing sine every time, I'm just going to replace sine of theta with x. It just makes a cleaner solution. So I'm going to say sine of theta is equal to x. We call that the dummy variable. So every time there's a sine, I'm going to replace it with x. So sine squared becomes x squared, and sine of theta becomes x. So now I have 1 minus 2x squared minus x equals 0. And now I can certainly resort to some algebraic methods in order to solve this equation. You can see, as you can see, this is actually, a lot of the solution to this is going to involve algebra, even though the original problem is a trigonometric equation. Okay, step 5 is to solve for the variable using algebra. So how do I solve for this? 1 minus 2x squared minus x equals 0. Well, first of all, I'm going to move the minus 2x squared to the front. Then I'm going to move the minus x in the middle and the plus 1 on the end equals 0, and I can see this is a quadratic equation, and because it's a trinomial, I can try the x method to see if I can factor it. A is negative 2, b is negative 1, c is 1. going to put a times c on top, -2, b on bottom, -1. Two numbers that multiply to give me the top are -2 and 1, and they also add to give me the bottom. -2 plus 1 is -1. So that works for my x method. Therefore, I'm going to break down the middle term into -2x plus 1x based on the sides of my x that I just got here. Then factor out a GCF for the first two terms, factor out a GCF for the second two, and voila. I'm going to use a little underline here. I have the same thing in the parentheses, x plus 1, so that becomes my first factor. My other factor is the -2x plus 1. And now I've factored this expression, and furthermore, I can set each factor equal to 0, so -2x plus 1 equals 0, and x plus 1 equals 0. Subtracting 1 over here and dividing by 2, I get, by dividing by -2, excuse me, I get x equals positive 1/2, negative over negative. And on the right here, I get x equals -1 by subtracting 1. So I've used algebra to solve for x, and now what? Well, that completes step 5, but remember this was originally in a trig equation. So for step 6, you need to replace the variable with the trig function. So instead of x, I'm going to replace it back with sine of theta, which is what I designated it to be in step 4. Same thing for x equals -1, replace x with sine of theta. So now we've got something to work with here, and we're one step closer to the solution. We have sine of theta equals 1/2, and sine of theta equals -1. Step 7 is to take the inverse function of both sides. We've definitely done this before. We know that the inverse of an original function cancels it out, and you're left with whatever's on the inside. For example, f inverse of f of x is just x. So in this case, sine inverse of sine of theta is theta. If we do it on the left, we have to do it on the right. And again, I'm just going to underline that to show what we're doing to both sides. So now we have theta is equal to sine inverse of 1/2. Same thing on the right-hand side. We're going to take the sine inverse of both sides, cancel out the sine, and we get theta is equal to sine inverse of -1. I'm doing that because I'm trying to solve for theta, and now I'm just one simple step closer to the answer. Now all we have to do is figure out what sine inverse of 1/2 is and sine inverse of -1. If you reach back into a previous lesson, we learned about inverse trig functions. For an inverse trig function, you're given the ratio and you have to find the angle. And that even alludes to that because it says theta equals. So if this is the ratio for sine, what is the angle that gives me the ratio of 1/2? Same over here. What angle gives me -1 for sine? And again, if you reach back and look at the original question, we want to look at this domain. Theta must be between 0 and 2 pi. So I'm only going to be concerned with that. That leads us to the next step, 8. I know that at pi over 6, sine is equal to 1/2. Okay, I can draw that on my unit circle here at 30 degrees or whatever, and sine is going to be 1/2. Depending on how you draw the unit circle, you might draw a 2 there instead of a 1. Or if some of you are more comfortable with this, because that might confuse you, this is 1/2 and this is 1. Same thing. And then over here, we know that at 270 degrees, or I believe that's 3 pi over 2, the y value is -1. So I know that sine is equal to -1 at 3 pi over 2. So therefore, sine inverse of -1 is 3 pi over 2. So always have that unit circle handy. And I almost forgot, there's another angle where sine is equal to 1/2, and that's at 5 pi over 6. If we draw the same triangle over here, we know that the height of that is also 1/2, with the radius being 1 for the unit circle. So I actually get 3 answers back here, and I definitely want to circle those because that's what we're trying to do, is solve for theta. Remember what the question is asking. It says solve for theta given this equation. So that kind of leads us to the next step. If theta is equal to pi over 6, 5 pi over 6, and 3 pi over 2, shouldn't we be able to plug it back into the original? And shouldn't both sides of the equation balance itself out? Well, yes, it should. So it just leads us to the last and final simple step. Step 9 is to check by plugging back in. So I'm going to plug in pi over 6 here for theta. I'm going to divide this into 3 sections. So I'll just go ahead and divide that now. In the middle, I'm going to plug in my second solution, 5 pi over 6. And in my last section, I'm going to plug in 3 pi over 2. I'm not going to go over this a whole lot, except you can see that on the left, you get cosine of pi over 3, which is 1/2, which is the same as sine of pi over 6, which is 1/2. You really need to know your unit circle in order to do these problems. So if you do not, you need to go back and review that lesson, which is up and available to you online. In the middle here, we get cosine of 5 pi over 3, which is also 1/2. It's in the fourth quadrant. Cosine's positive. And that is equal to sine of 5 pi over 6 equals 1/2. So our second solution, which was 5 pi over 6, checks out. You can see the same thing happens for the third solution. We get -1 equals -1. That's it for this example of solving a trig equation. If you follow these simple 9 steps, you will get the correct problem, the correct answer every time. If you have any other questions about this problem, let me know.